The question of whether this world is a ghostly apparition or a creation of quantum physics has long fascinated physicists, philosophers, and scientists. Quantum mechanics is a branch of physics that explains the behavior of particles at the atomic and subatomic level, and it has challenged our understanding of the fundamental nature of reality. The strange and counterintuitive nature of quantum mechanics has led some scientists to suggest that our world is not what it seems, and that it may be a creation of quantum physics. In this essay, we will explore the evidence for and against this idea and consider the implications of a quantum-created world. The nature of quantum mechanics. Quantum mechanics is a branch of physics that describes the behavior of particles at the atomic and subatomic level. It has been incredibly successful in explaining the behavior of particles, and it has given us a deep understanding of the nature of matter and energy. However, quantum mechanics is also a deeply strange and counterintuitive theory that challenges our understanding of the fundamental nature of reality. One of the key features of quantum mechanics is the idea of superposition. This means that particles can exist in multiple states at the same time. For example, a particle can be in a superposition of two different energy states, or it can be in a superposition of two different locations. This leads to the famous thought experiment of Schrödinger's cat, in which a cat in a box can be in a superposition of being alive and dead at the same time. Another key feature of quantum mechanics is the idea of entanglement. This means that particles can become entangled or connected in such a way that the state of one particle is dependent on the state of the other. This can lead to seemingly impossible effects, such as the ability to instantaneously transmit information over vast distances. The evidence for a quantum-created world. The strange and counterintuitive nature of quantum mechanics has led some scientists to suggest that our world may be a creation of quantum physics. One of the key arguments for this idea is the fact that our world is made up of particles that behave according to the laws of quantum mechanics. This suggests that our world is fundamentally quantum in nature and that it may have been created by quantum mechanics. Another argument for a quantum-created world comes from the idea of the multiverse. The multiverse is the idea that there are multiple universes, each with its own set of physical laws and constants. According to this idea, our universe is just one of many possible universes, and the physical laws that govern our universe may be different in other universes. Some scientists have suggested that the multiverse could be a consequence of quantum mechanics, and that the strange and counterintuitive nature of quantum mechanics could be responsible for the creation of the multiverse. There is also evidence from experiments that suggest that the behavior of particles at the quantum level is dependent on the act of observation. This is known as the observer effect, and it suggests that the act of observation may play a fundamental role in the creation of reality. This has led some scientists to suggest that our world may be a creation of consciousness, and that the act of observation by conscious beings may be responsible for the creation of reality. The evidence against a quantum-created world. While there is evidence to suggest that our world may be a creation of quantum physics, there are also several arguments against this idea. One of the key arguments against a quantum-created world is the fact that the behavior of particles at the quantum level is not directly observable. We can only observe the effects of quantum mechanics at the macroscopic level, and we cannot directly observe the behavior of particles at the quantum level. This means that it is difficult to say whether our world is a creation of quantum physics, as we cannot directly observe the quantum world. Another argument against a quantum-created world is the fact that classical physics is still a valid description of the world at the macroscopic level. While quantum mechanics is essential for describing the behavior of particles at the atomic and subatomic level, classical physics is still the best description of the world at the macroscopic level. This suggests that our world is not purely quantum in nature, and that classical physics plays a fundamental role in the behavior of macroscopic objects. Finally, there is also the issue of the measurement problem in quantum mechanics. The measurement problem refers to the fact that the act of measurement in quantum mechanics seems to collapse the wave function, which describes the superposition of possible states of a particle into a single state. This raises the question of how this collapse occurs and what role the observer plays in the process. While there are various interpretations of quantum mechanics that attempt to explain the measurement problem, there is still no consensus on how to resolve this fundamental issue. Implications of a quantum-created world. If our world is indeed a creation of quantum mechanics, this would have profound implications for our understanding of reality. It would mean that our world is not what it seems, and that there may be other possible realities that are equally valid. It would also mean that the act of observation and consciousness may play a fundamental role in the creation of reality, which would challenge our understanding of the relationship between the observer and the observed. Furthermore, the idea of a quantum-created world could also have implications for our understanding of the nature of time and causality. In classical physics, the past determines the future, and cause and effect are fundamental principles. However, in the quantum world, particles can be entangled in such a way that their states are dependent on each other, regardless of the distance between them. This raises the question of whether causality is a fundamental principle or whether it is an emergent property of the universe. In recent years, scientists have been working to develop new experiments and technologies to help us better understand the quantum world. For example, quantum computers are being developed that could one day revolutionize the field of computing by using quantum properties to solve problems that are too complex for classical computers. Additionally, quantum teleportation, where the quantum state of one particle is transferred to another particle without any physical connection between them, has been demonstrated in the lab. As we continue to study the quantum world, we may one day have a better understanding of its fundamental nature and its relationship to the macroscopic world. This could lead to new technologies and insights into the nature of reality itself. In conclusion, the question of whether our world is a creation of quantum mechanics or not is a topic of much debate and research. While there are arguments both for and against this idea, the scientific evidence suggests that quantum mechanics plays a fundamental role in the behavior of particles at the atomic and subatomic level. However, it is still unclear how this relates to the creation of our macroscopic world. If our world is indeed a creation of quantum mechanics, this would have profound implications for our understanding of reality, time, and causality. It would mean that our world is not what it seems, and that there may be other possible realities that are equally valid. It would also mean that the act of observation and consciousness may play a fundamental role in the creation of reality, which would challenge our understanding of the relationship between the observer and the observed. In conclusion, the question of whether our world is a creation of quantum mechanics is a fascinating and complex one that continues to challenge our understanding of the fundamental nature of reality. While there is evidence to suggest that our world may be a creation of quantum physics, there are also several arguments against this idea. If our world is indeed a creation of quantum mechanics, this would have profound implications for our understanding of reality, time, and causality. However, until we have a better understanding of the nature of quantum mechanics and its relationship to the macroscopic world, this question will remain one of the great mysteries of science. While there is no definitive answer to the question of whether our world is a creation of quantum mechanics, the scientific evidence suggests that quantum mechanics plays a fundamental role in the behavior of particles at the atomic and subatomic level. However, the role of quantum mechanics in the creation of our macroscopic world is still a topic of much debate and research. As we continue to explore the quantum world, we may one day have a better understanding of the fundamental nature of reality itself. On the other hand, if our world is not a creation of quantum mechanics, this would suggest that classical physics still plays a fundamental role in the behavior of macroscopic objects. It would also mean that our understanding of reality, time, and causality would remain largely unchanged. Overall, the question of whether our world is a creation of quantum mechanics or not is one of the great mysteries of science, and it is likely that we will continue to study and debate this topic for many years to come. As we continue to explore the quantum world, we may one day have a better understanding of the fundamental nature of reality itself, and this could lead to new technologies and insights that we cannot yet imagine.